Okay, here is a quick video on this homework. Pretty much problem 1, 2, 3, 10, and 13 all go together. And if you watched my previous video, you can follow that right along. Okay. Now, again, we're just using a 3V instead of a 5V. Okay, different numbers, good practice. Problem 22, this is where you can actually start designing your own. Okay. So we're going to use, we're going to basically look at this right here. Okay. So we're going to design a V-belt, specify the belt size, sheave sizes, number of belts, actual output speed, center distance. Okay. Do it in paper and then do it in Excel. Okay. And then I want calculations for 5V and 8V. Okay. So what you need to do is first look at this service factor. Okay, so typically the rock crusher, okay, this could choke. So we're going to use a service factor of 2. Okay, so what does that mean? Well, in here, your input power is 100. All right, so basically your design power now is going to be 2 times that. So your design power is going to be 200 horsepower. Okay. So the way you do this problem, kind of an outline, is again, you look at this service factor, determine what type you are, okay, calculate your design power. All right. Determine your ratio. So this one is going to be 870 over 625. Okay, so this should be about 1.4. So that's your velocity ratio. You can then pick D1 and D2 based on that ratio. Okay. Right? So D2 over D1 gives you that ratio. So you can pick those. Then you can find the rated power. So make sure that if I go back to this chart, so say you have 5E, pick one of these small diameters because they're labeled. Okay. Then you can multiply by 1.4 and that's your other diameter. Okay. So find your rated power. Okay, then you can find your center distance. And what you could do is you could pick, make sure something between D2, CD, CD, and 3 times D2 plus D1. Okay, so if you know your D2, you can find the center distance, and then this would be a number based on your values that's in between these, and that's the number that you like. There's going to be a range. Okay, you just pick one. All right, and that will satisfy. So it doesn't, the sheaves don't touch, or it's not way too long. Okay, so then you pick your CD based on that equation. Then you can find your length, right? And then use table 7.2, which should be the length, the actual lengths that you can get. And then find your corrected center distance based on that. Then you can find theta 1, theta 2, you can find C theta, CL, and then you can find your corrected power. And now this corrected power is per belt. Okay, so you can find the number of belts that you will need by taking your design power and dividing it by CP, your corrected power. That will give you your number of belts. So that will help you with this particular problem. Okay. All right. If you have questions, let me know. Have fun.